Hello, everyone. Um, Welcome to the Data Science Mentorship Cohort session. Right. My name is Pablo. I host the Data Science Mentorship Cohort. I'm the host, convener, and founder of the Data Science Mentor Program, which is an accelerated learning session for folks building their data science skills. And we're picking everything from scratch. We have recorded sessions like this for learners to jump on either live or when they get a recorded session. So you typically get a recorded session if you're signed up on the Data Science Mentor Program or cohort. Now, today we are doing a follow through from the sessions we had, the follow through from the last session we had, which was the second session where we're looking at line plots and basically looking at basic fundamental stuff. You can think looking at fundamental stuff like plots and axes and figures, and we're going to be looking at labeling plots, right? And we're doing this using line plots. So again, still basic stuff, right? Now, if you're to create a plot, it's important to label your plots with titles, axis labels, and simple legends, right? So we're going to illustrate this very simple stuff. As we proceed, it gets a little technical than the session we're having. So today, what we're going to do is we're going to plot generated data from using NumPy. We're going to have that plotted. If you haven't seen session 2, it'd be interesting. Please check out you would have received the access to the drive for it, so you can check it out. Right. So let's get started. So now what I'm going to do is I'm going to use plt.plots, so we can build a simple plot, right? And x, this is what we're using for x. Now, to put it in context, this is what x is. We had created x from the very beginning. We had created x from here, and so you can see x is generated linear values from 0 to 10 and 8,000 elements, or yeah, so that's typically what we have. And then we're visualizing them to make sense of line plots. We have checked out line plots using different parts. We have looked at line styles. You can see the solid, you can see the dash. We've also looked at colors. We've looked at colors, different ways to specify colors, either by name or by code or by HTML color names. Now we're going to be looking at labeling plots. So that's why I'm going to come back to X again, right? So first I'm going to use X, and then I'll use np dot sign, right? So sign of X is what we'll have here. Then now to put a title to the plots, you would use Matplotlib or the plt.title to get that done. So plt.title function makes it easy for you to create or to put a title to your plot. So this one is pretty simple. So this is a sine curve. So this is a sine curve. Now, the introduction is pretty interesting because a lot of the stuff we do here, we start off is pretty, it might not have a lot of intuition until we start to work with real data sets, right? Then initially you can see that this same sine curve over here, the x-axis or the y-axis doesn't have a label, and same with the x-axis. Now, to label it, we would use plt dot label. Now, the intuitive part of it is we have to define the x-axis, and you do that by saying x label. So here we just basically say x. Then we use plt dot y label. plt dot y label. Just give me a second, please. All right, so sorry for that interruption. It was a little technical issue there, but we're back. Right. So for the y label, again, we just just call this sine x, and, right? And so that's what we have, and then we plot. We use the plt dot show to render. We use the plt dot show to render. Right, so you can see that we have named our y-axis, right, and our x-axis. So you can see the x-axis is x and the y-axis is sine x. So again, very, very basic stuff, right? very basic stuff. Right. Now the positions and styles can be adjusted, right? And they can be adjusted using optional arguments, right? So there are many situations that may call for this. And so we're going to look at these situations. Now, one way we can look at it is we can think about it in terms of building different, having multiple visuals to it, and then we can start to think about the different ways we can label our plots, and that's what we're going to do. We're going to now build on this very simple labeling we have done, and then just keep pushing off ahead. Now, here is another way to look at this visual. I can basically say, and at this point I'm going to be looking at, at this point we're going to be looking at multiple charts, right, or multiple plots. Now, so here I say plt dot plot. Now, the first thing we're going to look at is we have x here, and we say mp dot sign, right, which was the first one we looked at. Now we put a comma, and initially, if you have watched the other session, you'd see that we looked at different ways of color grading our lines, right? So I'm going to be using that. So here I put a dash and a G as a comma, and then I can go on to put a label, right? And here I'll call this sign X. Right, now I'm going to go on to again plot this, say plt dot plot. Now with this, I'm going to say X, and I have mp dot cos. So this is like a cosine of X. That's what we use here. And then we would make another determination on how the line is going to look. Here we're going to put this sign or this mark here, and then we'll have to put a different color. Then we're going to give it a label. Of course, we're going to call this cos X. Now we can also determine stuff. We can determine how we want our plots to look, especially in terms of the axis, right? So here again, in the past session, we looked at that, where we can determine how our axis looks. If we can determine if we want our axis to look like an image, right? We can determine if we want our axis to be square, or we can determine a bunch of things. But here, what we are going to be doing here is that we're going to make the axis equal. So to do that, I can say plt.axis. And here I put equal, and then go on to say plt.legend. Now you see that looks a lot different than the last thing we have done. So if we plot this, plt.show, now you can see we have made some changes to this. Again, the focus here is one, the label keyword. We just introduced this label keyword here. You can see that the label keyword. Now, if you specify a label, then that means you are typically going to be introducing the legend to it, right? And so here you can see the difference here. We've now introduced this over here. And really interesting feature here, which we had done earlier on in the second session, again, for those watching for the first time, this is the third session, right? In the second session, we had looked at the introduction of coloring and then determining the kind of line styles we're going to use so they can be merged. So typically, you can see how this looks. And you can see at the same time, there's an equality in terms of our axis, right? There's an equality in terms of our axis and how they look. So by putting this equal axis equal, right, the axis will be sort of fitted to the figure, and so which makes it look pretty okay, right? Now, again, I just mentioned the plt.legend, which is this. You know, it keeps track of the line style and the colors, right? Really interesting stuff, right? And then it ensures that it matches with the label, right? So these are pretty simple stuff in terms of visualizing data. Now, there are a few things I would like to talk about in terms of Matplotlib, right? And we're going to look at them in different ways. Now, and so let me give this a heading. So let me just call this Matplotlib we'll call this Matplotlib I call it Matplotlib info. That's what I'll call it. It could be anything, but let me call it Matplotlib info. Now, when we started this session, right, there are two things we could do. We could either plot directly by using plt.plot, or we can plot directly to an ax method. And typically, the ax method is basically it's basically the axis itself. So there's a figure and there's the axis. Now, there are a few things we have to talk about, right? Now, some PLT functions can translate directly to ax methods, right? So some PLT functions can translate directly to ax methods. Now, when we say they can translate directly to ax method, what are we talking about? This is what we're talking about. And here's an example. We can say plt.plot, and basically, it's basically can translate to ax.plot, right? I think that's important to state. Plt.legend can translate to ax.legend. You would, if you take some online courses, you would notice that the authors interchange this, right? Right. Sometimes it's not always the case, right? Some you could make some difference. Now, it's important that I had mentioned this earlier on. There are two distinctions in Matplotlib. There's the MATLAB style function. There's the MATLAB style function, and there's the object-oriented method, right? So it's important that these two things, are often differentiated, right? In object-oriented interface, when you're plotting, right? Sometimes rather than calling these functions individually, it is more convenient sometimes to just use the ax method, right, to set certain properties. So you can just, use something like ax.set, right? So so I'm going to share some make some changes, and then I'll start to show you the kind of things that often happen when we talk about these different connections and their differences. Now, I'm going to plot, and then while I plot, right, I will show you how you can transition between MATLAB style functions. And for folks who are hearing this for the first time, the MATLAB style function is, because Matplotlib was, of course, inspired from using MATLAB, using them historically for this medical setup. So you would almost have what they call MATLAB style functions. And then once Python got into the business, when it was sort of moved out from that medical need to using, an open source and, and adding variety to the use of plots, we now had the object-oriented methods, which is inspired by Python. So MATLAB style functions and object-oriented methods make the following changes whenever you use these things. So it is important that you know that these things happen. For instance, there is, and we often use this MATLAB style because you can notice that I have used it here. You can see me using plt.plot, right? So as I'll state them, and then I'll go on to use some of them. And again, just so you know when you're using them in future, when there is interchanging of these codes and methods, you get to have a sense of what that means. For instance, plt.xlabel, which I used to create, I used to label the x-axis, can be translated in object-oriented ways as x.set underscore x label, right? So you can see it that way. Again, plt dot y underscore label, which again I used here to label the x-axis, and also be translated in terms of objects as x dot set underscore y label. Now again, I like to make reference to this because in the past, taking online courses, and you wonder why the author is using this instead of that. So these are translations. These are MATLAB style functions and object-oriented method ways of plotting charts. And you would notice some of this as we proceed, right? And we would make some of these changes. And I would, in fact, make a plot of it and then show you how, the difference. So which means we can decide to use x.set and then go in to use a lot of the different labels on how to use that. So just so you know that these things can be interchanged while working with them. Which other one can we do? We can also say plt dot. So now if you're looking, if you want to give your x-axis a limit in terms of numbers, right? You would typically say plt dot xlim. And this can be translated in terms of object-oriented as x dot set underscore xlim. Right. Same thing with plt dot ylim. Can also be used as pretty intuitively set underscore ylim. I think that's just about it. If there's any other one, I'll probably, if I'm missing out on anyone, it could be, you could intuitively learn this as you proceed, right? So here's so imagine a situation where we want to plot using the ax method. So we can basically say ax equal to plt dot axis. Go ahead, please. Oh, sorry, are you saying we can use? Yes. So in essence, Grace, what I'm saying is now, so well, I say historically, as there are two, in the beginning, MATLAB was typically what was used to do a lot of the plotting, right? Then there was the branch out to create the open source Matplotlib. Now, what that means is they still have different functions, related functions that still work, right? And so, in essence, if I say plt.x label, which is typically like the MATLAB style that is very popular, and then there's the object-oriented, where you now create an object, and then you connect to the object. You can see it here. See, create this object, and then you put this to it. Right. So yes, if you can, once you ensure you set the ax equals to this, and then from there, you can now manipulate the axis however you want. So that's what I'm saying. So you have to create this, and this is what I'm about to illustrate for you here. Right. So now you see that I have ax already set up here. Right. Now, just a little bit, let me just scroll up a little bit to the beginning of this session. And one of the first things we did when we started out was to show you that you can create, we can first create a figure. Look at that. We can create a figure like this, and then we can create an ax like this. So you can see this was where I introduced this. And once I create the figure, you see the figure is this empty canvas. And then when I ax, it's basically the axes themselves. So at this point, I can do, you see that I did that over here, right? And then what that meant is that I had to now use ax here and now say ax dot plot. Now, I want to emphasize on that. And when I emphasize on that, it means we will now see that this, it's a way we can build our visuals. And so that's why I'm placing emphasis on it at this moment. Now, so with ax, I can basically say ax dot plot. And typically, from the MATLAB style, we could typically have said plot dot plt dot plot, right? Now, with this, I can now put x. And for folks who are watching this for the first time, whenever we use x, this is what this x is, just so you know. So this is what x is, which is, we used lean space, like, a linear distribution between 0 to 10 and 100. So we have 100 elements here, or 100 values. That's what we have. So just in case you're surprised at why we're using x. Now, if I put x over here and I go on to say mp.sign, which is, we're getting the sign of, or we're getting the sign of our distribution there, and we're trying to visualize it. Next, we would now say ax.set. Now, with ax.set, a bunch of things can be done inside there. So if I come back here, you can see, we can put ax.set, and that means the possibilities are labels and limits. Right, so with ax.set, I can basically now take advantage of these guys in here, and I say x, which is the limit for our x-axis. We can say it's 0 to 10, right? And we have a limit for our y-axis, and I can say it's -2 and 2. Then I put a comma. I can also, okay, there's an error here. I can also say X label, which you can see, and then I can call this X or whatever I want to call it. And I can also say Y label, and I can call this sign from brackets X. Right. And then I can still come down here and I'll put my title. And I can call this I can call this illustrating a simple plot. And then I close this. And I can now go on to say plt.show. What do we have? What are we missing out on? We should have an error. There's an error somewhere. Right. So I think we're supposed to have like, am I supposed to have another this? No, something. Oh, I'm missing out on something, but I'll figure that in a bit. So this is one with this two here. Oh, I see where the error is here. Right. So you can see how that turns out. Right. So again, just like what we had done earlier on, right? It's just that we made this one equal. I think we tried to make the labeling here different, right? And you can now see it's just typically the same thing we're doing, right? So the thing is, with axe.set, you can set multiple properties at once. So again, it's ideal for us to put that here with axe.set. You can set multiple properties. Right, this is a thing you can do. Right, so that's typically it. So Grace says, is it still import matplotlib as plt? Is it still import? Yes, it is. As a matter of fact, it is. Again, if I go to the beginning of this, you'll see that was one of the first things we did. We imported this, right? And it's and so yeah, both of them exist inside of it. You can use both. That's the object oriented, and also the MATLAB is also is also embedded there. It's just that you can at the same time use any of them at any point to plot. So you can see over here, we did fig equals plt this, and then we can say plt.plot, right? And that's what we started to use. So that's why I'll advise that you watch the video before this. I'm sure you have access to it now, and you would see how we started from it. But it's a very good question. It's a valid question, right? So you can see how we started off with this. This is a fig, and then we can say plt.plot. In fact, most times we can almost always start without even saying fig, but we just say plt.plot, and then by default it will just when we should say plt.show, right? It will just evoke a new axis and a figure if there isn't an existing one, right? So that's basically how that works, right? And again, you can see here when we say the object-oriented interface, right? Right here, we said it feels like it feels like it's a more complicated operation because we sort of have more control over our figures. So this is what typically we did here. So with axe, we can create different plots, right? You see how we did that. We created two different plots and we can see them individually, right? But all in one I say axis, so to speak, or in one figure carrying all of them. So that's what we started out to do. Then of course, by default, most times we can choose not to. We can just we can choose to use the PLT sometimes, right? Again, you can see us using the object oriented here. But at some point, you can just do a simple figure and just basically say PLT.this, and it will just bring out the figure immediately for you, right? So it's just a question of what level of control do you want, right? So if you're visualizing stuff and you just want to visualize quickly, that's fine. You can just basically do a very simple, quick one, right? But if you want to define a lot of things, you can say, okay, let us start with my fig and the ax. And with this, we can basically say, all right, ax.plots, this is what it will do. Right. So just again, it's important to state this, because you typically see online courses and you're like plt.plot from nowhere, right? It's just by default it will show you a plot to work out. If you now decide I need to break this down in ways that are really important, then, or in ways that are far-reaching, then you can now call your fig and you can now call ax, and then you now start to go on to build stuff with it. Now, I would like to do a little introduction of a simple scatter plot. I would have loved to leave that for the next session, but I'll just talk about it. Then in the next session that we're going to have, we're now going to look at it in many ways. But I wouldn't record stuff on it, but I'll just talk about like a simple like what a scatter plot is. Right. So typically in understanding relationships, right, and to find a relationship between two numerical values, a scatter plot is almost always really interesting to use, right? And it is reflected with dots, circles, or other shapes, right? So that's what we are going to be looking at. That's what we're going to be looking at in future. And again, we could use remember, we could use the plt.plot MATLAB style function, or we can use ax.plot, to produce this line plots, right? But at the same time, you can use it to also produce a scatter plot, but there's going to be something really interesting with it. So we'll look at stuff like that in our next session. So imagine we have a situation, and again, it's just, this one is basic, and I'm just saying it's just as an intro. In our next class, in our next session, we're going to do a very structured way to look at it. But it's important that I just throw it in so that it will be a perfect segue to the fourth session. So imagine if we had, say, something called x_1, right? And x_1 will be mp dot clean space. Again, just so you know, clean space, evenly spaced numbers over a specified interval. That's what it is, right? And so we say we have a start 0 and stop 10 and the number of elements we want inside of it. Then we have y_1, and we say y_1 will be mp dot, let me say mp dot x1 here. So we get a sign of x_1. So now what we have now, we have two elements here. We have x1 and we have y1, right? So this is y is the sign of this guy. And then we can plot stuff, right? So just to give you a sense of what it is. And now I'm just going to say plt.plot. Remember again, Matplotlib style, right? So I just say x underscore 1, y underscore 1. And then I put a very, you see this, put this here, right? And oh, what did I do? This, yes. And then I'll say color, which is equal to black. And I close this. And I decide I'll say plt.show. So this is typically what you will get, which is basically what you have been seeing over here, right? But this time we just introduced it this way, right? Now, there's a lot we're going to do, right? There's a lot we're going to look at when it comes to building this scatter plot from scratch, and a lot of things we're going to be doing. But this is just like an intro to it. This was what we've been looking at here, but all of a sudden we just introduced this. And you can see how here I just didn't bother using an axe. I just went straight for the jugular there. So we're going to introduce a bunch of things just to look at how scatterplot starts in a very fundamental way. Then we now build from there. The interesting side to all this is once we keep building, we'll get to a point where we now say, you know what, let's put up a data set and then let's look at what the difference looks like, right? And then we'll start to, you know, make sense of it. And I trust you. Trust me, it's going to be very interesting when we now go from very basic stuff to start visualizing data in a somewhat technical way. So this is just the intro. Maybe just testing, just letting you guys know what's coming in our next session, right? So yeah, do we have any questions? All right. So again, if you are watching a recorded session, right, and I happen to say, do you have any questions? It's a cue for you to get to the Telegram channel and then drop a question, right? And then the interaction starts over there. But if you're watching the live session, please feel free to drop a question, right? You can drop it in the in-call message area, you can drop it in the comment section, and then we can interact with that. We have questions. All right. In the absence of any questions, please feel free to watch this all over again, right? And if you're feeling like, okay, there's something missing, just check out the resources shared with you. You see the second session there, which is where you will see an intro to what we have done. All right. All right, guys. So this is